Good morning all. Today we are going to start a very interesting topic, that is acceleration due to gravity, and it is from the chapter gravitation. Now before going to the topic, now let us refresh what you have studied in the previous class, that you have studied about the universal law of gravitation, that is the force of attraction, the gravitational force of attraction between the two objects of masses m1 and m2 is proportional to the product of the masses and inversely proportional to the square of the distance between them. And we can write that in the form of an equation, that is F is equal to g into m1 m2 by d square, where g is the gravitational constant and m1 and m2 are the masses of the two objects and d is the distance between them. Now let us start the topic with an interesting experiment, that in this experiment I am going to drop two objects. One is a heavy object, one is a heavy ball and a light ball, and I am going to drop it from a height. Now let us watch that experiment. What did you observe in this experiment? Yes, both the objects, the heavier object, the heavier ball and the lighter ball reached the bottom together. They reached the bottom simultaneously. So which one experienced more acceleration, the heavier ball or the lighter ball? Which one experienced more acceleration? Yes, both of them experienced the same acceleration, right? That is why that two balls reached the bottom simultaneously. So these two balls are falling under which force? Yes, that are falling under the force of gravity. The gravitational force is acting there. The gravitational force is pulling them, right? So this acceleration under this force of gravity is called acceleration due to gravity, and it is denoted by the letter G. It is denoted by the letter G, that is acceleration due to gravity. Now let us find out the expression to find out G, acceleration due to gravity. For that we need the universal law of gravitation that we already know, that is it is F is equal to g mm by d square. Now let us consider two objects. Here the object of mass m, it is the earth, that is the earth, and there is an object of small m mass, and the distance between them is r. And according to the universal law of gravitation, the force between them is F is equal to g mm by d square or r square, right? And we already studied the second law of motion, Newton's second law of motion. According to this, F is equal to m into acceleration, mass into acceleration. Here the acceleration is what? It is g, right? So we can write F is equal to mg. And now we are equating the two expressions for force. Now let us find the equation for g as g m by r square. That is acceleration due to gravity depends on the mass m, that is the mass of the earth, and r, it is the distance between the earth and the object. So we can find there is no term small m in this equation. That means the acceleration due to gravity is independent of the mass of the object. It is not depending on the mass of the object. That is why the heavier object and the lighter object fall to the earth with the same acceleration. That means both of the objects experience the same acceleration g, that is the acceleration due to gravity. Now let us test this with another experiment. Now in this experiment I am going to take a coin and a sheet of paper, and I am dropping them from a certain height. Now let us watch this experiment. So here you can find that the coin reached the bottom first and the piece of paper is delayed to reach the ground. But as per we studied before, both of them should experience the same acceleration and both of them should reach simultaneously to the ground. And now let us repeat the same experiment by crumbling this paper. I am going to drop the crumbled paper and coin from the same height. Yes, here you can find that both the coin and the uncrumbled paper reached the bottom simultaneously. So what is the reason for this difference? So when we know that here the room is filled with air. So due to this air resistance or due to the influence of the air, the sheet of paper is delayed to reach the ground. But when we crumble the paper, the influence of air is reduced. That is why they reached the bottom together. Now let me ask you a question. If I am removing all the air from this room, that is called the vacuum condition. If I am creating a vacuum condition and I am dropping the paper and the coin together, will they reach the bottom simultaneously? If the air resistance is completely removed, will they reach the bottom together? So let us watch this with an experiment that is known as the famous feather and coin experiment. Now let us watch the same.
Cameras on, 2, 1, release.
Here you can find that both the feather and the coin reaches the bottom together, right? So this experiment is called the famous feather and coin experiment. Now let us conclude that the acceleration due to gravity will be same for all objects. It is independent of the mass of the object. The G will be same for a heavier and a lighter object, and it will be same for a feather and a coin. It will be same for a paper and the coin. Now you have a homework activity. There is a famous experiment called Galileo's Pisa Tower experiment. In this experiment, Galileo drops a heavier object and a lighter object from the famous Pisa Tower. Now you have to prepare a write-up about this Galileo's Pisa Tower experiment. That's all about today's class. Thank you.